What I'd like to do now is introduce Hans, and you can see the title of the talk, the CQX CW transceiver kit, the story, the design, the development, 5 years of production and the evolution. And Hans is going to tell us all about that. It's the story of how the astonishingly popular CQX series of CW transceiver kits was born and developed. The technical design, the details, production challenges, keeping up with over 18,000 sales in 5 years, and the evolution of the CQX Plus and the CQX-mini.
QCX?
Sorry, QCX. And the future. Hans, if you don't already know, first licensed in 1994 as G0UPL, is a keen home brewer, never owned or operated any commercial radios, and after 20 years a corporate career in IT banking, Hans now runs the QRP lab kits full-time from his QTH in southwest Turkey. I bet it's warmer there than it is here. Yeah. So, without further ado, over to you, Hans.
Thank you very much. Yes, still early 30s centigrade, even here in October. We went for a swim on Sunday, so it's still very nice. I've given talks before about the technical side of QCX, and so, but because we only have really half an hour, as well as some time for questions, I wanted to expand it a bit and make it a bit less detailed on the technical side and give some idea about the whole story behind it. So, firstly, just some background, what is the QCX? It's a single band 5-watt CW transceiver kit. It can be built for any one band from 160 meters to 17 meters. It's distinguished by very high performance and features and yet a very low cost. So it first went on sale at $49 in 2017. And it's an analog design, so no SDR here, but it's all microcontroller augmented. Microcontrollers in charge of a lot of things. A lot of features, so it has a synthesized VFO, no drifting, and it has dual VFOs, keyers, memories, built-in test equipment, a lot of different features that the microcontroller enables. There are now 3 members of the QCX series. The original QCX Classic up here on the top right, which was the first one in 2017. And that was replaced in 2020 by the QCX Plus you see here in the middle and the QCX-mini at the bottom left. So this was retired in May 2020 and replaced by these 2. And they continue to be very popular. Sales continue every month, very nice rates, around 200, 250 a month. So it's very popular. Now, I know this will be very small, don't read it, just consider it to be a picture. What happened in the beginning, and this is why it's especially nice to talk about here at the RSGB convention, there was a letter from the RSGB, and in 2017, RSGB were hosting the YOTA summer camp in August 2017, and I had never heard of YOTA. I'm sorry, I'm not very familiar with all these acronyms, so I had to look this thing up, Youth on the Air, Youngsters on the Air, I mean. And so they have between 80 and 90 16 to 25-year-olds, and they all come over from all parts of Europe, or region 2, I think we are, aren't we? And every summer and get together and do this summer camp. And one of the activities they want to do is a build-a-thon. And so the RSGB were looking for suggestions for a kit to build at the build-a-thon. And so they had written here a budget. They have £1,000 to spend and 78 attendees from 29 countries. So I'm already starting to chuckle a bit in my brain, but I start to get the calculator out, okay, 1,000, and I'm thinking of everything in dollars because costs are in dollars and I'm selling mainly in dollars. And I converted it to dollars and it was $16. I was start laughing properly at this time. I always remember, because I spent 22 years, as you said, in corporate life, and Fridays were always the day when things went wrong. You know, people were tired at the end of the week, or bored, or they just about survived this far and the weekend was already on us and they were already in the mood by Friday afternoon. And so this was when, big scandals occurred or bad things happened, everything fell apart. It tended to be a Friday afternoon. And this email was coming on a Friday afternoon, so I thought, I wonder if that happens in the RSGB as well, right? So I deleted the email. Bam, delete. And however, as the afternoon wore on, I kept coming back to it in my mind. What if I did this? What if I did that? What kind of thing could I propose? And I knew that you could do something for 12, 13 pounds, something like a very simple 2-transistor transceiver or something, and like a Pixie or one of these very small rigs. But I think there's such a thing as too simple. And particularly when it comes to beginners, like many of these youngsters were beginners, there's such a thing as too simple. And you need something that you can actually operate, that performs well, otherwise people will be put off and they'll go and do something else. The first QSO I tried to make was on a Pixie transceiver that was 2 transistors, and all I heard was noise, interference. I couldn't do anything with it, and it puts you off as a newcomer. So I wanted to make something serious, and I started turning over in my mind, and by the early evening I was in my deleted folder finding that email and undeleting it and typing out a proposal to Steve Hartley, wasn't it? Steve Hartley, G0FUW, and typing out a proposal. And this was my basic proposal, which was very close to the final QCX as it was finally implemented. I expect many of you have a QCX. Who has a QCX here? Wow, that's quite a few people. So SI53518 synthesized VFO with rotary encoder tuning and RIT, and screen with CW decoder, Kia, for a couple of watts. I said a couple of watts at that time, but it later became 5 watts. Single band only, I suggested 40 meters. RSGB decided they wanted 17 meters, and you know why, don't you? Because it was 2017. Who would miss such an opportunity? But I thought 40 meters would be better because there's more activity and it's easier to have a QSO. But anyway, it was 17 meters in the end. With proper single sideband, so no unwanted sideband double conversion stuff going on, and proper output filtering, and even we wanted to have a key on the board itself. I was always conscious that I was designing for the buildathon, RSGB buildathon, and there were not going to be 78 kids there with Morse keys and things like that, so it needed to take that into consideration. 13 days later, so that night, I hardly slept. I was lying in bed, and this was all turning over in my mind. What will I do with this, and how will I do that? 13 days later, this was my first prototype, and had the first QSO on 40 meters. And all the final parts of the design are actually here. This was our main kit at the time, the Ultimate 3S, and it comes with an enclosure. And so I had a front panel with the LCD bolted to it, and I used that as the screen. And everything else bits and pieces of board all put together. And you can see down here is a micro switch, which I used as the Morse key. So for the design, I was going to try to get really high performance and innovate to get high performance and low cost together. Because traditionally you think cheap is crap. You can't have a good transceiver and a cheap transceiver at the same time. So I wanted to challenge that concept and get a really high performance to price ratio, which is how the QRP Labs kits are known for sort of innovation and high performance to price ratio. So now I want to take you back slightly to a little bit of a rant which I have. Who remembers these two? You do. Yeah, I see. Now who remembers these two? Less people. Okay, we're radio amateurs. That's cool. Okay. Madonna and Michael Jackson. I am, of course, talking about the 1980s. And the 1980s was when the Signetics NE602 chip was introduced as a second IF mixer and oscillator for cell phones. It was intended for 40 megahertz IF. It has 17 dB of gain in it, and a mixer and an oscillator, and of course it's a very nice small 8-pin package, inexpensive. It was very quickly discovered by radio amateurs. And I call it the Cold War sandwich, and I've been calling it that for a few years very disrespectfully, because it comes from the 80s. And even today there are still commercial rigs on the air which use exactly this same, not on the air, for sale, which use exactly this same topology, a Superhet with 2 SA602s and a crystal filter in the middle, and that's their receiver. And the first reference I could find to it was mid-80s in a Signetics data book, and by 1987 it was already in the June edition of Ham Radio as a receiver design. So my issue with that is, one, we've been copying that for 35 years ever since, and two, that it doesn't even work that well. It works very well as a second IF for cellular, but it doesn't work very well when faced with an HF antenna. And the issue is the low dynamic range and a quite low third order intercept of minus 13 dBm, which means you get all this strong signal intermodulation products. And I really learned this when I built a 0 to 140 megahertz spectrum analyzer in 2003. And I saw all of, see, this is looking at a signal here, the fundamental and the second harmonic and third harmonic and fourth harmonic. But all of these other things are artifacts from intermodulation. And they're quite significant, you see, and that's all because of this limited low dynamic range, limited third order intercept. And you find if you tune the signal, these artifacts move faster, 3 times, 5 times faster, because it's all harmonic mixing products. So that's one thing that's wrong with the 602, and there are just better ways of doing things 35 years later. Direct conversion receivers using the SA602 are also quite popular, and a lot of people like the clean sound from an SA602. When you put the signals through a crystal filter, it's not a very well-designed crystal filter, you can get ringing and group delay, which causes the sound to sound a little bit tiresome to the ears. If you use a direct conversion receiver, it's beautifully simple. You don't have birdies from mixing products, you don't need all the shielding you would need with a Superhet, and you don't have all the issues with aligning the BFO and with the filter edges and so on. But on the other hand, you hear both sidebands, and you also have issues when you've got all the gain audio. You can have issues with hum and microphonics. So a solution to this is the phasing method direct conversion receiver, which is nothing new, was even done in the old Valve days. And in this receiver, you apply a 90-degree phase shift both at RF and at AF. And some mathematical magic later, the sines and cosines all add up and subtract, and you end up with the wanted sideband being doubled and the unwanted sideband being nulled out completely. And so you get an SSB receiver without any, it's like a direct conversion version of an SSB transceiver without needing a crystal filter. But again, you still have the issues with all the gain being audio, and there's a lot of things to think about. It's ideal for SDR, and nowadays many receivers, even microwave, cellular stuff, is all done with but conversion down to baseband, I and Q, and then using a software-defined radio to do this 90-degree phase shift. But as I said, this is an all-analog radio. So this is how phasing method direct conversion works. And a very nice mixer for that was popularized by Dan Taylor and is often known as the Taylor detector. And it uses a 1-to-4 multiplexer switch. These switches are very common. They have this FST3253 bus switching device, which is a very low-cost chip. And just with that and a quadrature oscillator, by the way, it's much easier to apply the 90-degree phase to the oscillator than to the RF, because if you apply it at RF, as you move away from one frequency, the 90-degree phase shift will deteriorate. And as your amplitude is not balanced and your phase shift deteriorates, the unwanted sideband cancellation gets worse. So it's much easier to apply it to the oscillator. It has very low loss and very high IP3. Dan Taylor quoted plus 26 dBm. So when you compare that to minus 17 dBm, you've got almost 40 dB extra of dynamic range on this compared to a SA602 mixer. And that's from his patent. He patented the idea many years ago. There was a receiver in 2004, transceiver rather, in 2004 called the NC2030 by the NorCal QRP Club in California in the US. It outperforms on third order intercept dynamic range many of the big names at the time. This graph is from a presentation that Dan did. And you see here the NorCal 2030 really at the top of the table on quite a few very well-known receivers at that time. And they sold that for a while as a kit costing $150. And in many ways, the NC2030, people have said that QCX is like a modernized version of the NC2030. It's not really. I mean, there are very, very many number of differences between the QCX and the 2030, but it certainly is a very, very big inspiration for the QCX. This is the, I'm just going to run through some of the technical details now in this part of the talk. This is the double balanced quadrature sampling detector. Double balance is created by this trifilar transformer over here that splits into two 180-degree phases. Double balance is important in a direct conversion receiver because it gives you common mode rejection. So it means you have AM broadcast rejection, and it makes a lot less problems with hum and so on, which you can get in direct conversion receivers. And QCX doesn't suffer from those problems. All the gain is audio, but it still doesn't suffer from those problems. A big part of that is having the double balanced quadrature sampling detector. And we have 4 integrating capacitors at the output and then 2 differencing outputs to produce the I and the Q channel. These could be fed into a PC or software if you wanted to do software-defined radio demodulation of the sideband. As I said, in QCX, we do everything in analog. The oscillator is the next big thing. The oscillators, you always have problems with drift if you have an analog oscillator. Other types of oscillator, like synthesizers, long ago used to be very complex, require several circuit boards worth of circuitry to make a good synthesizer. Direct digital synthesis chips have been out for a few decades, but they produce quite a lot of spurious products, and they're also quite expensive. Along came, I think, around late 2014, this amazing chip, the SI5351A. And it has inside 2 PLLs and 3 divider stages. Everything is configurable with fractional multipliers, fractional divisions, and you get 3 separate synthesized outputs. And all of that goes on in a 3x3 millimeter square chip that costs less than $1. And so it's an amazing, imagine that was several circuit boards worth of components, and now we have all of that costing less than $1 in this tiny 3x3 millimeter blob. And that really, really enables a lot of what we do and really lowers the cost. The output is a 3.3 volt square wave. You might think, okay, well, we want sine waves for the oscillator output, but it turns out for the quadrature sampling detector, a square wave is exactly what you want, and it's the best way and the most accurate way to drive that mixer. It's configured by I2C, which is a serial protocol using a microcontroller that tells it what frequency you want and how to get that. It has very, very fine resolution and a frequency output range officially from 3.5 kilohertz up to 200 megahertz. It's a very, very wide range and very accurate over that range. You can feed in to this pin, either you can connect a 25 or 27 megahertz crystal, or you can feed in an oscillator signal from a TCXO, for example. It's also used in the Elecraft KX2. I have the greatest respect for Elecraft, and so if they put something in their rigs, I know it can't be that bad. So next thing is the power amplifier, and I had been fascinated by Class E power amplifiers for quite some time and trying to make one that worked, and I'd always failed. I never managed to get anywhere near the efficiency of Class E. And the point with Class E is that transistors are saturated as switches, and you have a resonant load here, and the energy gets dumped into that resonant load and pumped out of that into the low-pass filter at a very high efficiency. So they can easily reach efficiencies over 90% if they're very well set up. And the important part of that is that you don't need any heatsink because the transistors are not dissipating too much power. And what I have in QCX is these 3 BS170s, which are very cheap, very common. Well, they were very common until recently, not so easy to find now. But you get a very high efficiency amplifier with no heatsink. That was important for this particular project. Why? Because we wanted low cost. And no heatsink means I don't have to pay for heatsinks, and also the board is smaller because I don't have to make a place for heatsinks. So that was a very important development. And it was the first time I'd actually got a Class C amplifier working, and I developed my own sort of what I call the ghetto method of designing Class C amplifiers, which is not involving too much mathematics at all, just using the website to calculate for the resonant circuit, which consists of this inductor and the capacitor C30, what is the component values to get a 50 ohm impedance, and the low pass filter is 50 ohms, and then the rest of that is all done experimentally. And so that actually works. So I was quite surprised by that. It probably doesn't give as much efficiency as 90%, but it does pretty well. Now, break-in QSK is another important feature for many CW operators. In break-in, it means you can hear the other guy in between your dits and dars. so you hear the band. And it's quite useful if you've just called a DX station and suddenly you hear that he's answered somebody else, and there's not very much point you continuing to try and call him if he's already talking to somebody else. So you can hear all that sort of thing, and it gives you a very nice sort of presence in the band. It feels like you're in the room with the operator on the band. And so many people like that, but relays, if you use relays for transmit receiving switching, they slow everything down, they're expensive, they're bulky, and in the end they're a mechanical component, and if you use them a lot, they start failing. And so I wrote here at the end, solid state, great state. If you can do all of this in solid state with diodes and transistors, then you end up with a very fast, high-performing transmit receive switch. So this is a very simple switch in the QCX. The demands on it are quite low because it's not linear with lots of linear power amplification stages. All we really need to do is isolate the receiver from the power amplifier, and that's done by this MOSFET here. It's all under the control of the microcontroller, so the microcontroller takes care of the timing to make sure everything is sequenced properly. Then these I and Q channels are fed into this op-amp network, which is lifted straight from the NC 2030 design and elsewhere, which is called an all-pass network, and the signal you get out of the other side is, they start off with a 90-degree phase shift at the beginning, and at the end one of the channels is shifted 90 degrees relative to the other one. And what happens is the upper sideband is shifted 90 degrees in this way, but the lower sideband is shifted 90 degrees this way. So at the end, you simply add them up with this potentiometer, which balances for the amplitude, and the in-phase signals double in amplitude, and the out-of-phase signals from the opposite unwanted sideband simply cancel out. So it's a very neat trick. After that, there is a 200 Hertz bandwidth CW filter. This is from another of my heroes, David Kripe, NM0S, of the 4 States QRP Club, called the Hypermite. He did this filter design. And it's a very nice, sharp filter with a 200 Hertz bandwidth, but carefully designed to not have ringing and to sound pleasant. And so when I heard that, I was very happy with it and decided to use it in QCX. And I contacted Dave, and he said, yeah, great idea, go for it. And so that's what we use in the QCX. And then at the end, just a very simple audio amplifier consisting of one more op-amp. These op-amps are strong enough to drive earphones, the standard sort of mobile phone 32 ohm earphones directly without any problems. And so that's what I use. And then there's a muting switch here which helps mute any residual transmit signal which creeps through the transmit receive switch and leakage during transmit. And a volume control there you see on the left. Now on to microcontrollers. Microcontroller is really the heart of everything, and I'm using the Atmega 328, which is the same chip that's used in the Arduino Uno board, very famous computer board, but we're not using the Arduino at all, or any of its infrastructure. It's all programmed in C. There's a tiny bit of assembler in there, and it allows us to put so many features into the radio without adding more hardware. So, for example, the side tone is generated in the microcontroller, and the side tone you can change the volume by configuration in the microcontroller. You can change the frequency of the side tone by microcontroller configuration. There's a keyer. It's controlling the oscillator chip. Remember, it has an I2C serial interface. It's got all the dual VFO, the splits, frequency memories, preset message memories. So I use it as a CQer. I just press the button and it sends the CQer of my call sign very quickly and usefully. And of course, putting everything on the LCD. These LCDs are very cheap and also very convenient. They're very easy to read, big characters, easy to obtain. And we show both the VFOs or single VFO if that's in use. There's an S meter, the battery voltage is read by an ADC pin and put in on here, decoded CW, which would stretch across the whole bottom half if you were not using the split VFO. So really the microcontroller enables loads of features. And one of the interesting things that I added here was this concept of having built-in test and alignment equipment. I imagined this whole room of people and the RSGB people running around like headless chickens trying to organize all these kids building stuff. And you weren't going to have lots of debugging equipment, oscilloscopes, signal generators. And the worst thing I found when I had been looking at earlier projects was you read through the manual, at a certain point it says, connect your signal generator or tune to a strong station, and that's how you do your alignment. And often you wouldn't have those things. So I thought it was very nice that we include all of this inside. So it's got a signal generator, a voltmeter, RF power meter just by this simple detector diode here, a frequency counter, and the signal generator can also be used as a signal injection into the receiver front end. And then that can be used to align the amplitude balance and the I and Q phase adjustments so that you null the unwanted sideband. And all of that you do with the unit by itself without requiring any additional equipment other than a dummy load. Bonus feature was added, which was the Whisper weak signal propagation reporter transmitter. So you could connect the QCX to a GPS, and the 1 pulse per second is used to calibrate the frequency reference for the synthesizer and to set the time, the location, so that it can transmit Whisper. Bringing all of that together, this is the block diagram of the radio. All of this is online in the assembly manuals, by the way, if you wanted to look at it later. So that's just how all the things we've just talked about fit together. Development from February to August 2017 was assisted in this case by the junior lab technician number 2, who was 21 months old at the time, and he came up and heard this scratching outside the lab door, and he's opening the door and comes in slowly, and he walked up to my chair and he said, "Go." And I had to get off my chair, and he climbed up on it, and he put the finger on the key, and he started tapping away at the micro switch key. I thought that was great, and listening to the side tone. Anyway, there were so many stages to it. The RSGB decision came in April. I had to finalize the circuit, PCB layout, do a final prototype of the PCB layout. Firmware was a very big thing. And remember, I've never owned commercial radio receivers, so I don't even know how it's supposed to work with dual VFOs, A and B and split, and all of this stuff. So I have to go around asking my friends, what does it mean? How is it supposed to work? How am I going to develop the firmware so it behaves like one of these proper radios behave? And so I had to ask about all of that. Component sourcing would be even harder to do today, but this was all things I had to do between April and August 2017. There's over 150 pages of documentation that also took a very long time to prepare that includes operating, description of how to build it, and the theoretical description of how it all works. 1st of August it launched, and I had this idea that the first 90 or so that I had subsidized for the Yotta would all be sent to Yotta, and the other 410 I'd be able to make enough profit to cover the subsidized, and I had this idea. I could never imagine how fast 28 hours later those 410 were all sold, and it just, the tsunami just kept coming after that, and as of now we're over 18,000 in 5 years, so some kind of record. The Yotta was very successful. I didn't hear any complaints. There were some bugs in the software, things that needed to be improved in the hardware, but minor things. At one point, there was a 10-week waiting list in late 2017, and it was just purely because we were trying to manufacture boards and get parts and ship them all out, and it was just too much attention all at the same time. To date, so this was on Thursday when I updated this, 18,472 kits have been sold of the QCX series. So it's huge. Biggest challenge is the support, because there's a percentage of those people who need help getting it working, and I have to provide that remotely by email, which is not always easy. Popular with SOTA, CW newcomers, even new constructors. So there was a third-party enclosure. I think that was late 2018 by a German company, Bamatech, made from this bent aluminium. And they solved one of the problems with the original QCX, which was all the controls, the buttons, the screen, the rotary encoder, the gain control, everything was at a different height relative to the board, and the connectors were on the two sides. So it was a very bad mechanical design, which I knew, but I just didn't have time to do any better in that April to August 2017 rush. So I had accepted that as a compromise. And they built this case with extensions for the rotary encoders and the buttons, and that was very nice for a while. There were software enhancements, such as a cat control serial port. There was a 160 meter version was added, side tone improvement, real-time clock display, which is updated from the GPS if you have it attached, but is not persisted from one power cycle to the next. Endless minor requests and minor bug fixes, but generally it's been very stable. So there's been a lot of work going on in those 5 years. Additional members of the QCX family, there was a 50-watt power amplifier that I developed, which has on board pin diode switching for transmit receive. So that was another very interesting development, as well as a low-pass filter for one band, as well as a nice enclosure with these 2 heat sinks on the top outside the enclosure. So you put a keying line to the QCX that controls switching between transmit and receive, and the sound when you listen to it is like a normal QCX with 5 watts. The QSK is so smooth, the 50-watt amplifier doesn't interfere with that. So that's been very popular as well. May 2020, I decided I finally want to solve these issues with the mechanical design of the QCX that had been bugging me, like itching me all this time. So I decided to do a QCX Plus, which was a bigger board. Unfortunately, I don't have a picture of the board in the presentation, but as well as a nice enclosure. It goes back 14 centimeters here, 10.5 centimeters wide, and 58 millimeters high, I think. So it's the same firmware, same design, but just a better physical design with a front panel PCB with all the controls at the right height to be sticking through the enclosure, and a very professional black anodized enclosure. People ask, why do I make it black? But you look at all our radios, Icoms, Kenwas, Yaesu, everything is black. It's tradition. It indicates quality. So that was why I made it black. It also had a development kit that came very soon after the QCX Plus was released, which was designed to fit on top of the board and had all these connection points so you could put headers between, and we supplied a lot of hardware and connectors for sockets and pin headers so you could make connections between the boards. People use that for adding audio amplifiers, batteries. You can fit the GPS module inside, drill an extra hole in the rear panel for the SMA for the GPS antenna, things like that. So that's also quite popular with people who want to modify, and there's plenty of room inside the QCX Plus enclosure to do modifications. We also started an assembly service, which was useful for people who are old, infirm, lazy, or rich, which increases, the price increases, and so this was taken on Thursday, a whole bunch of QCX Plus is ready to ship out to people. So we have 5 employees in Turkey who are all local people from the area, and who I have trained to do assembly and testing of QCX Pluses and QCX-minis, as well as the shipping and packing. The next development after QCX Plus, so a bunch of people who said, oh, QCX Plus is very nice, it's a little bit big, it's bigger than the old QCX was. We want to go mountain hiking on SOTA. I bet if I asked you to put up your hands if you've done portable. Oh, there's a lot of people. I'm not even going to say it. I was going to say people. I'm going to say it. I was going to say people dream that they're going to go portable, and that's why they buy the QCX. But really, they're just going to sit in their shack and maintain the dream. But you guys are different because obviously you have done it, so it doesn't apply to you. Anyway, same design, same firmware, same schematic, same everything except miniaturized, and a lot of surface mount components on the top and the bottom of the PCB, all of which are pre-assembled by the factory, assembly factory. So that's what the board looks like, and you recognize the same trimmer controls for the adjustments of the sideband rejection and all of that. Same everything, just miniaturized. Then 2 additional things to add was TCXO. That's on the left there, and this board is tiny. It's about 11 or 12 millimeters wide, and it fits into both of the AGC module and the TCXO fit into this area here. You see there is a TCXO on this one already installed on top of the SI5351A. So those are options which, if people want to do whisper, the frequency stability provided by TCXO is very useful. Some people like AGC, so this was an AGC module that was developed in our user community and I just implemented on the PCB. Both of these are very low cost optional additions if you want to. So I'm watching the clock, don't worry. Endless challenges in the last couple of years have been very tough. There was the pandemic and kids being home from school and needing IT support for their Zoom classes. Oh, Daddy, my internet froze, and I have to go running up and down and fixing it. There's been component shortages, as I'm sure you all know. The SI5351A chip just disappeared out of production. When I heard that it was getting in short supply, I went to DigiKey and I bought the last 1,500 they had. And I went to Arrow and I bought the last 2,500 complete reel that they had. So I had about 4,000 stock at the beginning of the shortages. But that was used up in a few months, and then we're in trouble. Fortunately, the Chinese have made a version called MS5351M, and there's nothing to indicate that this is any kind of fake or clone, other than just a reproduction of the same functionality. So I don't think you can call it a fake or a clone. I did a lot of testing on some samples, and the performance is actually slightly better than the SI5351A in terms of the output amplitude and the phase noise. It consumes a couple milliamps more supply current. That's not really important in our application. We had problems with op-amps. There were fakes in the supply chain. So the first couple of batches of QCX-mini that went out, about 10% of the op-amps were failures. And I don't know if they were fakes or pulls or rejects or what, but their 5 op-amps have the same part number, and they're about 10% fail. In the second batch of QCX-mini, I had a 38.5% failure rate. So I literally had to get more op-amps and personally remove more than 1,000 of those 8-pin SMG chips and replace them with working versions, and then retest everything to make sure that it was still working, or that it was then working. So this has been a big challenge. Mega 328s have gone through phases of being unavailable or being 3 times the normal price. There was a big panic at one point. I couldn't find any in DigiKey or RS or Farnell or anyone. And then I thought to look at the Turkish distributors, and one of these guys had over 2,000 listed on their website. So I quickly called my wife, come, bring the credit card, we've got to buy these things. 15 minutes later, we had a phone call from the company, and I was expecting them to, this company, Direnç, Turkish company, they like me so much, they send me a book at the end of each year, you see. And I was fully expecting this guy to say, no, sorry, our stock level on the shop was wrong, we're going to have to refund all your money. But instead, he said, you made a very big order, so we want to give you a 5% discount. So it was very nice, and the chips turned up, and we had 2,000 to continue. And so, for all of these challenges, we've been able to continue with the growth of the company, and the sales have continued to grow year by year. Probably without these troubles, it could have grown faster, but at least we're still in business and still growing, so it's very nice. And thank you also for all your support on that in buying these kits. So for the future, I imagine personally that I will make other radio designs in the future, but we will continue to keep the production of the QCX, because I think a monoband CW transceiver that is easy to build, particularly the QCX Plus, is very easy to build and very educational, good soldering practice, because it's all through-hole components. I think there's always a place in amateur radio and in my own heart for a monoband CW transceiver, so I have no plans to retire that. I want to keep that going. However, I often call it the last analog transceiver. I'm sure it isn't the last analog transceiver, but it's probably my last analog transceiver, because for my more recent things like the QDX digital modes transceiver, I've gone to using an embedded SDR, which I think is the future. And the reason for this is simply you can get higher performance. You can get higher performance with a lower parts cost and a lower parts count and a lower cost. It's easy to then implement firmware updates to add more features. The power of that, even in QCX, we were able to do that to an extent because the microcontroller was controlling everything. But with SDR, it's so much easier to do that. So I think, higher performance, lower cost, it increases the performance to price ratio. My radios in future are going to be using embedded SDRs, but we'll keep the QCX going. So that's very much the end, and thank you very much for listening. The last slide got slightly corrupted because I use Linux and LibreOffice, not Microsoft, but you can still see the idea. Both the QCX's kits are £51. In the current currency, they were a little bit less before, but the pound hasn't done so well recently, and everything is based in dollars. The enclosures start from £18 for the QCX-mini, and there's a few pounds more for the bigger enclosure of the QCX Plus. The links are on there for QCX Plus and QCX-mini, and the link to the shop. I should have put my email on there if you wanted to contact me, but it's very easy, just hans.summers@gmail.com. Also, you can put your inquiry from the website. So thank you very much for listening, and hopefully some questions. Thank you.
Any question? Oh, right. Here we go.
I don't think you could even see it because I was standing in the way here. I saw you kind of looking around me at
Right.
points.
I'm Mike Naylor, G4CDF. You mentioned very early on that you didn't choose to use the digital. I've lost the name now. Instead of the synthesizer you
DDS.
use, the DDS.
Yeah.
Yes, I built the Picastar
Mm-hmm.
when it was going in Redcom, and that uses DDS. And in fact, he improved the DDS by use of a different device. I admit they're expensive, ish, and
I
but
think
they
you
do.
used the AD 9910 or AD 9912.
It was a 9951, I think
Right,
it was. I
yeah.
used in the end, and they're not cheap, but they do provide a sine wave
Yep.
output, which is
Mhm.
an advantage in some
Some
situations.
cases. Mhm.
But it used one of the Talo mixers in there, and it
Mhm.
worked really well.
Mhm.
I didn't find any problems with the DDS
Yeah.
in terms of spurious, but it was
Yeah.
a high-end DDS, in fact.
Yeah. With DDSs, the spurious get worse or get better if you have a larger bit depth,
Yeah,
and they get better if you have a larger ratio between the reference frequency
Yeah.
and the output frequency.
yeah,
So the 9910, 9912s have a 1 gigahertz reference,
Yeah.
and at HF that's quite a ratio, so you don't have the spurs problem.
mm,
And it's because it's a stepped approximation of a sine
Mm.
wave. You make the steps smaller
yeah,
and more steps per cycle.
yeah.
But I mean, yeah, it comes down to cost.
Yeah,
And
that was the next question, was on the cost. You mentioned using SDRs. Now, I've seen there are some very cheap SDRs for receive only, but I've not found any that do transmit as well that are cheap.
it comes down, I think, to implementation.
Mhm.
This talk is not about that, but my
No,
next
I understand,
product
yeah.
has been the digital transceiver, the QDX.
Mm.
And that's different because it's single tone transmission rather than SSB.
Okay. Right.
I don't see any reason why it should be more expensive.
No.
The QSX is another design I have in the works, which is a sideband transceiver.
Mm.
And again, when I was designing that transceiver, I considered analog, and I
Yeah.
chose SDR because it reduces the cost and increases the performance.
It's just our radio club is doing a club project based on SDR, and we started off with the Lime SDR, which is duplex, but it's now become very expensive,
Yeah.
the price. We're looking at another one, Caribou, I think it's called, Caribou Light,
Oh, I don't know that.
and that's over £100 though. You know,
Yeah.
so I was just wondering how you solve that
I mean,
problem.
in SDR, a lot of the stages are still analog. You still
Yeah.
have to do a linear exciter, SSB exciter, and driver and power amplifier, and all of that is still linear.
Yeah.
Or you have to use Class E EER envelope
Mm.
restoration, but I don't think that's cost effective to do well either, not at these power levels. And so I don't see any reason why it should be
Okay.
expensive, other than a lot of people have had problems with parts, and getting parts has been expensive. I've had to be quite nimble in the last 6 months, 2 years
Yeah.
time
Well
frame in stepping around all these parts problems, and it's really slowed down a lot of things.
Yeah, thank you.
Any other questions?
Anybody else?
Thank you. Thank you, Hans. That's completed the loop for me, because now I see the bloke who was responsible for me and some others, maybe in this room, who were involved in Yota 17
Yeah.
and watching people get their fingers pricked with winding toroids.
Yeah.
Now, if you can solve that problem, that would be wonderful. But an excellent presentation. It really has completed the story, and thank you.
Thank you very much. And the problem with toroids is that if you use molded inductors, the Q is not high enough, and so it's a performance thing. You use toroids in output amplifiers even at 5 watts. Even in bandpass filters, you can notice the improvement in performance. If you use molded inductors, it becomes the limiting factor in the performance of the receiver, the non-linearity of that inductor core. So toroids are annoying, but necessary. Yeah.
Victor Brams, G3JNB. Thank you, Hans. Excellent presentation.
Thank you.
Quite expected to be at that level. Thank you for the QCX. And to anyone who is just wondering about the amplifier, I have the 50 watt amplifier running at 20 watts. It is magic. Thank you.
Thank you very much. Any other questions?
Any others?
These are observations rather than questions.
Yeah. Okay, well, thank you very much, Hans, for a fascinating talk. And can we show our appreciation, please?
Thank you very much. Thank you.
Well done.
Thanks for coming. Good turnout.